Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, and our guest today is Dima Feldman, VP of Product Management and Marketing at Sony Semiconductor. Sony Semiconductor is a leading provider of cellular IoT chipsets for wearables, vehicle telematics, smart utility meters, and other devices. And in this talk, we discussed the evolution of the cellular chipsets from 1G through the IoT chipsets CAT-M and NB-IoT that are enabling devices today. We also explored the rollout of 5G and the implications of low power, low cost, and high reliability connectivity solutions for IoT business model innovation. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Thank you.
Dima, thank you so much for making time to join us today.
Hey, Eric. Thanks a lot for the invitation.
Okay, so Dima, I'm really looking forward to this conversation because it's on a topic which is related to a technology I use every day. I mean, really, probably, unfortunately, probably 16 hours a day. But that, is kind of embedded in all of the solutions I'm using. So I never really touch it. I never really understand it like I do some other technologies. So the conversation here is around semiconductors. But before we get into Sony Semiconductor and the work that you're doing there, I want to just understand your background a bit. So can you've been working at Sony for quite a while since, I guess at Altair before Sony purchased it since 2007. Can you just walk us through a bit your path to joining Sony and then some of the work that you've been doing at Altair over the past, 13 years now?
Yeah, of course. Yeah, it's actually never thought I'd going to work for so long for one company, but actually it's pretty fun. It's great. And actually, we are based in Israel. Altair Semiconductor was based in Israel as a headquarters and obviously Sony Israel. Like many other Israelis, you go to the university, some do army after that. Altair was pretty much my first job after completing this Israeli path, I would say, of university and a few years in the army. And I've started at Altair as the RF or RFIC lead. We started developing the new RFIC. The company actually started as a WiMAX those days. We had a great digital technology, good software engineers. We pretty quickly realized that if you want to be successful, you have to own the entire solution and all the key components of the solution. And the first task for us was to bring on RFIC technology. And we started with outsource. We built a team. And I was really in charge of that and actually go with the company as the company grow. Later, I've spent a few years in Canada for relocation with my family, working a lot with North American customers. Coming back to Israel, I've established the solution architecture team and later the product team. And recently, I've been appointed to VP Product Management and Marketing at the company. So pretty diverse route within the company. And I think this is one of the reasons people like working for this company, because you can start at one position and really have a lot of do different things, both vertically and also be promoted through different management ranks. And as a company, maybe, which is probably more interesting, so we started with WiMAX. 2008, we have realized that WiMAX is not going to happen or not in a massive scale. And we have shifted to LTE. Our first solution powered all kinds of data devices like tablets and portable routers. And this kind of business grew and was actually very successful. However, in 2016 or slightly prior to the acquisition by Sony, we have realized the IoT market is probably much bigger and really looking on the things that communicate to other people. And on one hand, and smartphone business is very crowded and basically dominated by huge players who are entirely focused on that and spend teams of multiple thousands of people, we made a decision. We focus on IoT. And this is when Sony acquired us in 2016. Within Sony, we part of or mostly part of the IoT business solution unit, which also doing, so we do the cellular IoT. The other groups are doing communication one type called Altair, which is a homegrown in Japan. And this is mostly uplink type of communication where a device sends few messages a day, and Sony provides a full service. The other team is the GNSS team, which is very successful and well recognized for extremely low power consumption devices. And they power probably most of the wearable market today, including Garmin and other companies. Not sure how many of them I can mention. So we as a team, we work really on communication technology, the location technology. There is also some processing capabilities within the group. Those capabilities both across the company and also being focused by or led, at least our business unit or Cellular IoT is led from Israel as a business unit. We can utilize the technologies within Sony and being fairly independent with a huge backup of Sony and to approach the market. So this is a great thing for us. And maybe the other piece we do in Israel, and this is less known because it's part of Sony, we also develop a AI computation engine for Sony Semiconductor. And you probably know that Sony Semiconductor and Solution is one of the biggest sensor provider globally. We do AI computation there, but I would prefer to focus on IoT on this call or on a podcast.
So thanks for walking us through that. Before we get into the technology, I'd love to stay here on the business for a few minutes. And you've mentioned developing IoT chipsets and kind of segmenting that, from the mobile market. Makes sense. I'm really interested in understanding more in detail how you segment the IoT market, because what I find is every company, has their own unique perspective on what the market looks like. And because it's such a fragmented market and it can be defined by industry or by, asset type or by requirement like low power, et cetera. There's no kind of standard definition for what the market actually looks like. How does Sony segment the IoT market from a chipset perspective?
So I think probably the formal definition would be it's where the things communicate and personal or people are not involved or mostly not involved. So this probably would be the first way to distinguish. And for me, things could be literally anything. I can, give me an object and I'll find a way why it should communicate with the cloud. So, could be, a speakerphone, it could be a mic, it could be my mouse. You can have or a speaker. I have now use a speaker for this conversation. And it would be nice if my IT manager will know where the speaker is because it's pretty expensive. Or I will get a notification if its battery is about to die in the morning. So here I took a stupid object, a speaker, and I found a way why it has to communicate. So there are so many use cases for devices to communicate. Saying that, there would be several segmentation within the market. I'm not sure it's a formal or not. One would be, and this is from technology perspective, one could be high bandwidth applications like cameras. Camera is a thing and it transmits video. So it's definitely within the market. But from a technology perspective, it of course totally different from a temperature sensor I might have or electricity meter I have outside my door. And once a day it will report electricity usage. So it's different use cases, but it's all things. So I would say there are devices that are high throughput, low throughput. I can say there are devices which are very time critical, like V2X. My vehicle communicates to the next vehicle or to the infrastructure around it. So it's very low latency, high reliability communication versus, again, low latency, or we call it usually on 3GPP, we call it massive IoT is the huge number of devices with a small amount of communication. I would say there are also the other way to classify it and say some devices are connected globally whenever you go and they use a cellular connectivity, or whenever they are located. The meters never go, never roam, but they use cellular connectivity, while some other devices, especially within our houses, you often use Wi-Fi Bluetooth connectivity. So I would say indoor devices versus indoor devices, which would be typically consumer electronic devices versus B2C or B2B devices, which will or typically would use the cellular networks because of the higher quality of service. So it's very different ways to describe it. Does it make any sense to you?
Yeah, that does make sense. So, so you kind of describe it based on the functional requirements of different types of solutions, and does that kind of map to your portfolio? Because I guess what I'm kind of trying to get at here is, what does it look like for you? You know, on the one hand, you have, as you mentioned, you've got thousands of different, probably thousands really, of different categories of devices that could be connected. And each one has kind of unique requirements, but then you can't build 1,000 different products for each kind of mini category. So what does your portfolio look like? Is it that you have kind of 5 different chipsets for different situations, or are you heavily, I guess you still do a fair amount of customization for your larger customers, but what does this look like from a portfolio perspective?
I think I'll start with the end. I think IoT market, unlike smartphone market, which is maybe cellular as well, and I often think about cellular as the holy grail, but there are so many other technologies as well. But this is my focus. So IoT is very different from cellular devices because or cellular smartphones, because they are so different. And this is where I can easily say we don't play in a smartphone market, and we definitely have this low power wireless area IoT, and those are totally different devices. In terms of portfolio, we have those small sensors, extremely low power with a battery life of 10 or 20 years in some cases. We have devices with a little bit higher throughput, for example, for cameras upload. But I think, and this is us as a Sony Semiconductor Israel, but they all focused on connecting things, not people.
Yeah. Okay. Clear. And then where would you sit in the supply chain? So, I mean, obviously Sony, the larger corporate, they sit at many locations in the supply chain, right? But your business unit specifically, are you selling directly to OEMs? Are you being integrated into larger modules? Where would you sit, or who would be your direct customers?
Let me answer this maybe in a second, and maybe I want to field the answer from your previous question. I think IoT, and you touched a little bit customization for the larger customers. And I think interesting thing about IoT is that the market is so diverse that you don't have many huge customers. It's not like you have Apple and Samsung who are 20% of the market share. There are probably thousands of device makers. And therefore, this would lead me to 2 conclusions. One is you should not customize, or you are hardly customizing the solution for your customers, because this way you are not scalable to meet or to serve most of the market. This also brings us to your second question is, how do we address the market? And if you go and look on the traditional cellular market, and I'm looking this more from the cellular perspective than IoT, maybe perhaps. If you look on the smartphone, people usually provide chipset to the smartphone builders, and we call it chip on board. And it can only work for very large volume devices, because the overall infrastructure or the ecosystem of the cellular business is quite complicated, with the amount of certification and regulatory body we have to work with, and therefore does not necessarily make sense for smaller volumes. And so for really big devices, we will go directly. It would be maybe, I would say, as an example, a big wearable guy or a very big smart meter vendor. So maybe for them, it could, in some cases, could make sense to do chip on board. While for others, we'll go through channels. We call them our module partners. And it's interesting because each one of them has a different specialization and different support body and sales organization. And some could go for really small customers doing really devices in magnitude of hundreds, or thousands of units. You can think of a company who want to do smart garbage collection for your municipality. They don't. It's those not always huge companies, and we will address those kind of companies through one kind of module maker, which often will bundle hardware support with maybe connectivity services or even cloud services to enable really quick time to market. While for other markets, we'll typically work with very high quality. Actually, all of them are very high quality, with the high quality module makers who can address bigger markets or maybe being a little bit more cost optimized. So I think there is a really big range of the ways we can address the market, starting with direct customer support for strategic accounts, and going through one or in some cases even two module makers like staggered to address really small customers.
Got you. And the module, I'm actually not so familiar with that market. Is that the market of module makers? Is it also quite fragmented, or are there a handful of companies there that are composing, 40, 50% of the total market size?
I would say it's probably about 10 or 15 companies. Well, I would say about 10 companies who compose 80% of the market. It's a traditional market. Maybe 5 or 6 years ago, it was called machine-to-machine communication. And this is where most of the module makers came, because at that time, where if I look historically, maybe there was a machine-to-machine market, or it was too small to be addressed by chipset companies. And what happened is module makers would take chipset design for a smartphone and modify it, or strip down, or do some software customization to serve the machine-to-machine market. And there are a few very established module makers in this space, like Sierra Wireless is one of the biggest. And they're really experts in this market, and they have channels, and they understand the actual challenges of their customers and device manufacturers. Or they sometimes even come to the service manufacturer. Somebody wants to do smart mousetrap, and they will help him to build the mousetrap, because guys know mousetraps. He doesn't know cellular. So those are the more traditional and provide a lot of services. Looking among our channels, we also have more IoT guys, or which doing more like I would say hardware-oriented modules. Companies like Sercom or Murata or Winstron who serve global market. We also have a few more in Japan, which specialize on the Japanese market. So some would specialize on global market, and some would really specialize on the local markets. What modules for me means, and maybe this is why their value in the ecosystem is so important. When we work with the module maker, he will make the design. He will go and certify it with the regulatory agencies like FCC and RED in Europe, or TELEC in Japan. And he will also go and achieve carrier approvals like from AT&T, Verizon, Vodafone, and there's so many. Actually, I hate saying name because I will definitely miss somebody. But all the big carriers have certifications. So the module makers will go and achieve those certifications. By doing so, when I'm a small company doing mousetraps, I don't have to approach those certification bodies. And I just use the module, plug it into my board. In some cases, even bring connectivity with the module. And I am ready to sell mousetraps. And I think for me, it's maybe one thing about the IoT business is when I'm in a discussion with a device maker or maybe end customer, he would typically know his business quite well. So it could be mousetraps, it could be smart meters, gas meter, water meters, or logistic tracker. They are really expert in what value they bring to their customers, what are the relevant use cases, and what are the challenges they have, and what, if in case of materials, what are the materials that water meter has to be built from so it can withstand for 20 years in very humid environment. They're expert in that area. And therefore, it is important for me and for module maker partners is to offload all the difficulties of the cellular ecosystem for those guys and really let them focus on their core business and let us and the module makers solve the challenges of the cellular networks.
Okay, Clear. Okay, good. So that makes sense. And then I suppose companies like ARM, so design companies, and then the cellular networks themselves, I suppose you'd also be in close contact with them. How does this work with ARM? I mean, are they a competitor to any extent, or are they purely a partner, or other similar companies?
Well, ARM is such a diversified company. You probably know they do processors, they do some silicon IP, and they now do some cloud services. And we're also in touch with them actually in a very close cooperation for a technology we call iSIM, integrated SIM. This is another piece which built to simplify the overall complexity of the solution. If you think of SIM technology, in the 90s when it was introduced, it was introduced in late 80s, but in 90s when we started to use the phones, even before the smartphones, we would use the SIM card to store our contact list, the text messages we send, because it was so difficult to type them in, and our credential, my phone number. So if I would swap a phone, I would take a SIM card from one phone and plug it into another, and my phone number will go with this action, and also all my contacts, which was a great deal at the time. And the SIM involved in that, there are a few more functions it can do, but essentially it's there to serve the way you identify yourself versus the network in a secure way. And even today, if I buy one smartphone and tomorrow I buy the next one, I move the SIM from one to another, and I keep my subscription, and I use now cloud services to back up my contacts. But if you think of an IoT device, it typically won't have a phone number. Well, it actually has a phone number. You would be surprised, but this is how devices work on the network. But nobody is calling my smart meter anymore or sending him text messages. Also, it doesn't need to have a contact list because he's not going to call or text anybody. It's all IP or data communication those days. But for the cellular connectivity communication, you need to have the phone number as an identity and the security credentials. And we are no more flipping those between meters or different IoT devices. So therefore, there is absolutely no need anymore to move a physical card or SIM card from one IoT device to another IoT device. And actually, pretty logically, many players in the industry came to the conclusion. And actually, I'm really happy to be probably the first one, or absolutely the first one, to commercialize it, that say, okay, the physical SIM card is not needed. The soldered SIM card, which is another version, is no more needed. We can have a secure SIM credentials on the chip, on the modem chip. And this is where ARM with their ecosystem also come into the game, and we provide the hardware. In this specific partnership, they can provide the software or SIM credential working with the carriers. And together, we have a smart piece within our chip, which is now your plastic SIM card. Actually, the chip itself is half of the size of the smallest SIM card anyhow. So we really don't need those SIM cards anymore. And this is where partnership with ARM comes into the game.
Okay, interesting. Yeah, I suppose the SIM card is so large just because our fingers have to be able to pick it up, right? So a lot of that space is just a handle, basically.
Yeah, but you definitely don't need it in the IoT. Also, having the one thing is maybe the functional or the logical piece of the SIM card, which we embedded. But the other one, if you think, all those IoT devices has to be many of them has to have a very strong ingress protection because they live in a humid environment. Nobody wants people to play with them. And therefore, leaving any physical port for a SIM card could jeopardize the device functionality in field and also create a security risk. I can have a electricity meter. I just pull out the SIM card, and it does not report the readings anymore. So it's really, the use case has changed. And I think the industry has to change with it. To be honest, we are not doing it only with ARM. We have additional partners in this industry, in this specific space, because it's all about ecosystem. I think specifically for IoT, the overall solution is still, I would say, a little bit complicated because there are many parties involved. and many standards. And if you build the right ecosystem around you, because maybe some partners want to prefer one specific vendor over the other, and therefore you typically have to build a pretty rich ecosystem around you. So when you go to the customer, he can always choose the relevant players from your ecosystem.
Good. So let's move now into a bit of a deeper conversation around the technology. So cellular is a kind of a set of technologies that I think many people have a very high level understanding of, and few have a deep understanding. I'm one of the many that have a high level understanding here. So maybe you can give us kind of a 101 course on what are the different cellular technologies. LTE, CAT-M, NB-IoT, we have 5G coming around the corner. What would be the key cellular technologies today, or that you're expecting to be relevant in the near future? And then how do they differ from each other in terms of the functionality that they provide?
But let me first define, maybe for sake of other audience, what cellular technology is. And it comes from what cellular is. And cellular means that we have many cells within our city or surrounding, and our devices communicate with cells. It's maybe a different way from Wi-Fi, which will communicate typically with the only access point I have at home. In a cellular technology, the entire idea is that operator, which is typically a big company who buys spectrum, which is a very expensive asset, could be billions of dollars. They buy spectrum, and they put many cell towers that will use that spectrum to communicate with the devices. So this is, in essence, what cellular network means versus maybe Wi-Fi, which is low-range or short-range networks in our homes, or Bluetooth, where we typically have a device-to-device communication, and each device can talk with each device. In cellular network, the idea is that my device talks with the cellular tower, which is going to talk with the cellular network, and the other way around. So this is, in essence, the cellular technology. And between the technology, though, there was a long time ago, it all started analog, then 2G, which is started at 80s and still exists and deployed, and slowing down only now. So it's 2G. It started for a voice conversation, and maybe it's important to say that cellular technology started for people to replace the landline. So it started with with a voice conversation. Text messages was actually a next service on top of that, and very naturally the people understood, or we realized that we don't want to have only voice. Now we want to also transmit data and videos. And today, voice is actually a very small portion the entire traffic on the network, and most traffic is our rich content like videos and photos and music. So you can see that there was a shift from the voice technology to the voice payload to the data payload, and networks had to be changed accordingly. And this is where 3G came first, or HSPA networks replaced the 2G networks because they could provide much better data, or provide the data traffic in a better way. The next level, and maybe one bit technology, but when network was built to bring voice from one side to another, those networks were not based on IP technology. It was based on a packet switching technology, where you basically got a specific payload or specific time where you could transmit your data, and no advanced protocols like IP, which are used today everywhere. And the first IP-only network was LTE network, which started deployment started in 2008. And this is the LTE, what we call the LTE. Some people call it generation 4 or 4 plus. And LTE network started with category 3, which was the baseline was 100 megabit per second downlink, 50 megahertz per second uplink, which is pretty decent throughput, even probably 10 years ago. Even today, it's pretty decent, and started about 10 years ago. From that direction, cellular communication globally adopted the LTE technology, and this was a big change because almost no more regional specification like different one in China or US. Pretty much aligned globally, which was an LTE, and this was a very big change. And if you read the specification of the smartphones, you'll often find category 4, 6, 12, 16. it all means higher throughput, but the underlying technology is absolutely the same. And the higher technology you have or higher category you have, the more throughput you have. So this is what happened to the LTE network. At some point, this is where was actually enlightening for us. We said, well, you don't have to run after the throughput because IoT devices or most of the IoT devices don't need that. Also, 3GPP realized that, and instead of doing higher categories like 16 or 20, etc., there was a split. Some devices went to achieve higher categories and higher throughput by using more and more spectrum, while other devices say, well, we need to slow it down. We need to generate really low cost and extremely power efficient devices to meet the IoT market needs. And this is where CAT-M technology came to the game, starting from release 13, probably 2005 or 4 was defined. And only now it's starting its massive ramp up. So this is why CAT-M was invented. CAT-NB was invented roughly in the same time. More political, I would say. CAT-M was driven by 3GPP and US-based company. Chinese companies wanted to have their own proprietary technology. And Huawei went through the acquisition of a startup in the UK. And this is how NB came into the world. I think so. It was initially a totally competing technology, serving very similar needs. However, I think one of the good things that happened is that it was also adopted by a certification body called 3GPP, which is the certification body for cellular. So one, we have two slightly competing technology within the same standard. Or maybe it's not optimal, but the good thing that we have all the competing technology under the same body. And this is extremely important for the ecosystem because nobody stands by himself. And once we have a rich ecosystem, we can build and scale up. And I'm really happy that all those standards are under the same organization body. And this also means that same cellular network and same cellular towers support all the categories. So it's all kind of a 4G and for a 5G. And actually, CAT-M and NB is also part of the 5G. But do you have more time to talk about 5G, by the way?
Yeah, absolutely.
So 5G came with 5G known for one thing, but it's actually three totally different pillars. 5G is a kind of a marketing name for a new generation of technology. And it came to meet three different pillars or three different target applications. One, and this is what most of the people call a 5G, it's called enhanced mobile broadband. This is where our devices transmit more and more data and receive more and more data. I would say it's kind of native or logical continuation of the higher categories. So we need to have more data because all of us use much more data. Our kids use a terrible amount of data as well those days. And so this is the enhanced mobile broadband. So it came with a new radio on the same cellular frequencies, but it also brought additional spectrum available because laws of physics are still in place and we need more spectrum to transmit more data. And therefore, 5G uses much more spectrum also at sub-gigahertz space and even in millimeter wave. So this technology, so suddenly the cellular technology is expanding into the more spectrum. And this is what most people call 5G. But the other two pillars are one, I would say, one is called ultra reliable communication or ultra low latency communication. And this is a different segment. It's intended for vehicle to V2X, vehicle to infrastructure or vehicle to vehicle communication, where you don't need to send tons of, you don't send videos between the vehicles, but you want to send information in an extremely reliable way. And it's extremely delay agnostic. So it has to be very short messages sent very quickly. And same goes for the industrial IoT, where you can have in the factory one machine with the camera and another one with the knife. And you want the camera to detect that the piece of shit came and you need to cut it, and you have to give a command very quickly to the knife. Maybe I'm doing a bit of simplification, but this is what you need for the industrial IoT, where very quick communication.
Dima, sorry, just let me interrupt you very quickly. So you've just introduced two of the pillars of 5G. Is it that these pillars can be thought of as functionalities, and any 5G network or any 5G enabled device would have all three?
No.
Or is it that one device? Okay, so 5G is a larger set of technology, and device by device, they might have one or more of these.
Yes, you can imagine, because you could imagine that while for the mobile broadband, you will communicate with a tower and tower with a network, and it comes with certain latency. When we have a V2X communication, then my vehicle wants to communicate to your vehicle. It doesn't have to go all the way to the tower and the core network and back, because it will add the delay. So it's a different technology and different use case, but it's still under the umbrella of 5G. And the third pillar is actually more similar, or uses exactly the same infrastructure as the first one. And the third pillar I was waiting for is the massive IoT pillar, where the target for the 5G was our cellular network has to support over 1 million devices per square kilometer. It's a lot of devices. And this is the third pillar. So for us in the IoT, this is actually, I would say, 90 or 95% of the things we do is covered by this pillar. And the good thing or interesting thing that CAT-M and NB, you mentioned before, are actually meet the requirements. So whatever we do today is already 5G massive IoT. It's built for that. So the more devices you bring and the more core network capacity you provide, the devices stays the same. And this is actually a great deal and help us to scale up today. The CAT-M technology and NB technology is the 5G IoT technology.
Okay, very interesting. So I have a question about the potential impact of 5G on IoT deployments. This is a bit of an internal debate. Well, we've been speaking with different people and have gotten a number of different opinions as well. The question is, what will be the impact on edge computing in particular? So if we look at 5G technology, one group of people says that when 5G is deployed, it's going to allow devices more bandwidth, higher latency, et cetera. It's going to basically make it easier to do edge computing, because you'll have this very robust network that connects maybe devices around a factory or within a city, and can then enable more compute on the edge. And then another group of people are saying, actually, it's making edge computing less necessary, because these devices can then be connected to the cloud with very high bandwidth, low latency solutions. So it's actually not necessary to do edge computing. You can just move everything to the cloud. I mean, obviously there's costs involved there, but do you have a perspective one way or the other on the potential impact of, is 5G going to be supporting, let's say, edge computing or cloud computing more or less, or do you think that's just maybe not the right way to think about it? It's just more on a case-by-case basis?
Yeah, I don't want to be categorical. I think it's really case by case. And I think both camps are pretty much right, because even today we have devices with extremely small bandwidth that can do a lot of edge computing. For example, let's think of a camera who, maybe in Corona days, it's really important, can count how many people came into the shopping mall. So we can have a camera with a lot of processing on the edge that can count people, and it will only transmit the number, how many people are in the mall. So we do an edge computing here. Theoretically, we could stream up all this video to the cloud with the 5G and do everything on the cloud, but then maybe the battery power consumption of the edge device would be much higher, because it has to transmit all the data, and maybe the overall system is less efficient. So this is actually the claim why the second camp may be right. But I can also think in another way that you have an edge computer which receives a lot of data from the edge itself, but it can also augment it from data from other edges or from the cloud. And so I would say both are right. And also looking in perspective into the computing market, the more traffic we have, the more flexibility we have, the more bandwidth we have, the more flexibility we have to spread the computing load. And we can say, okay, if I can transmit everything to everywhere, I could actually put the load in the right place and further cost optimize and performance optimize the solution. While in my first example that I gave you, if I have only a very narrow pipe and I cannot upload the video, then I'm somehow limited with what I can do on the edge, or if I want to augment it with additional. So, for example, I have two cameras and I want to augment it into one or one data processing unit, and I suddenly can't because I don't have enough bandwidth between the two. I think your assessment of case by case is pretty much correct.
So if we look at the big categories today, I suppose we can kind of list a few of these. Here we might be looking at things like smart sensors, cameras, et cetera, that you've mentioned. We have CAT-M, we have NB-IoT, we have 5G. We also have non-cellular solutions, so EP1, et cetera. What trends are you seeing in terms of adoption of technology by the device manufacturers? So if we look at, I don't know if you want to compare CAT-M versus NB-IoT, or maybe we can bucket those together. But there's also this kind of open question around when we'll actually start seeing devices ready for 5G. I think mobile phones, it's a little bit easier because there's very large companies that are pushing that forward. Devices is much more fragmented. How do you see the adoption trends developing among the ecosystem right now?
I'm a little bit biased because we do cellular. I can make a very strong case why I think cellular is better than other technologies, which are LP1 as well. You call themselves LP1. And I would say for maybe three main reasons. And not saying that there is an adoption of only one side, but I see benefits. And I think one benefit is cellular exists everywhere. So if I go to my house, or if a utility company wants to install a smart water meter next to my house, they know that cellular networks is there. If they are about to deploy their private network or some kind of LP1 technology, quality of coverage is not as good. And I think this is one advantage of cellular. The other advantage of cellular is the spectrum is licensed. And this means that somebody paid a lot of money to use it, and he can guarantee quality of service. This is unlike unlicensed spectrum where some technology can use it, but I can bring many other devices or totally unrelated devices transmitting on the same frequency, and suddenly the quality of service will be highly degraded till not available. I would say the third point is security. And as we deploy devices that have to live in the field we have now a customer who wants to deploy for 20 years. So it's amazing. The devices has to work till 2040. And they have to be secure because this is a critical infrastructure. I think many think that working with a technology which is more mature and the standards are being written by multiple people, and I would say maybe many thousands of man years has been invested into write them and make those standards truly secure and interoperable. This brings some people to think that cellular technology is much safer to use from cyber, in terms of cyber attack or denial of service attack compared to other technology. And I think this is also important. And this is why I think cellular technology is a better fit for most, not all actually. I do see some use cases like, I would say, agricultural farms where having a local network could make a lot of sense. I do see advantage in cellular. And as I said before, CAT-M and NB is already 5G. So you don't have to think twice you have to think twice, but you can easily get the guarantee.
If I have an NB-IoT chip installed in a device today, does that mean that when a 5G network comes on, I'll be able to use that? Or is it that maybe I need a newer generation of NB-IoT? Or if I have something that was maybe deployed 2 years ago?
You will use it. And I think this is I cannot express it. It's super important point, because people who deploy now devices that will stay in field for 20 years have to guarantee that they will work for 20 years. And I think it would be fair to assume that in 10 years or 15 years from now, the LTE networks that we know from the smartphones will probably shut down, most of them, and we are going to have 5G. And therefore, it is critical, and this is super important, and this is how standards are built, that CAT-M both CAT-M and NB, will work with 5G base stations. This is really a fundamental assumption.
Yeah, I was thinking about this the wrong way. I was thinking that each device, as it is kind of goes through product development, would have to be modified to enable 5G, and it sounds like that's already the case for any CAT-M or NB-IoT.
There is some testing. I don't want to say whatever works now, no issues 5 years or 10 years from now. Maybe there would be some firmware upgrades to fix some bugs. But the way the standard is built, it's fully interoperable. And those are actually the testing we do now in the background with the infrastructure vendors to make sure that this is actually the case.
Gotcha. Is that a trend of shifting the functionality away from hardware towards software so that it's more flexible over time, or how do you view this?
I would say yes. It's not only for chips, there are certain things you have to do in hardware, but software gives you more flexibility to develop and adjust and optimize. I know that maybe it's not my core expertise, but I do know that for the network infrastructure, there was a significant movement from hardware-based base stations to more and more software and cloud-based solutions, also for the infrastructure. So yes, definitely there is a significant shift towards software.
So Dima, we've talked about kind of the status quo and then also about 5G. Anything else on your radar that you're really excited about in the cellular world?
I think what I'm excited of is, I would say in the last 12 months, we see a big growth of cellular IoT. By itself, it's really exciting and to see that something you work on and dream on is actually happening and ships in volume. One thing that we're starting to see is more and more use cases coming into the game. This has been first it takes to mature the use case and understand that this is what you want from a business perspective. And then you need all the technology pieces. But yes, we see suddenly you can, if in the past for logistics space, you had to track a container or maybe expensive pallet, suddenly you can track a parcel or a bag of seeds. And so I think one thing that I really see happening is more diverse kind of application and use cases. And for me, it's extremely exciting.
And from a marketing perspective, is there any type of 80-20 rule where 20% of the use cases are providing 80% of your volume, or is the market so fragmented that you're just responding? And are you able to kind of target it and say these are the X number of categories that we're going to prioritize for the next year?
I would say one steady market, which is really, really steady, is the smart metering market. It's been determined by number of households and the pace of replacement. So it's really steady and pretty big. I would say it takes a significant portion of our volume. I see logistic market growing, I would say, exponentially. So I don't know when it will be bigger than the other markets, but it's a really exciting one.
And the connected vehicle market, is this something that you would serve, or is this more the traditional kind of high performance cellular type chips that would serve autonomous vehicles?
I would say for vehicles, there are many, many different needs. Definitely one of the needs, which is V2X, this was the second pillar of the 5G, and somebody else will serve it. But there are other segments within vehicles that are related to tracking the vehicles, monitoring the engine, the battery, doing all kinds of preventive maintenance. And the different trends. Once there was an idea that we can unify all into a single radio, but now we see a trend where actually different manufacturers say, well, I don't want to rely on anybody else. I want to have my own car telematics. So you could think of a vendor who will say, I'll monitor the engine with one radio, and I'll do the multimedia with other radio, and the smart driving or autonomous driving with a third radio, totally different. So vehicles are extremely complicated and super fragmented. So I would say we will probably cover only a portion of that vertical. Still in every vehicle, right? It's a big volume, but you cannot do all.
Of course. No, it's funny you mentioned that. Probably, every other week or so, I have a conversation with a component manufacturer who's trying to figure out, we know our components are very important, that they produce a lot of high value data, but we're only components. So how can we access that data? How can we build a business model around that? It's a challenge, but you can see that there's a strong incentive to, have control of the data that your components are producing.
Exactly. And maybe one thing to mention that really enables the latest development is we spoke slightly about cost when I said that we were one of the reasons for CAT-M and NB is to reduce cost. I also see significant or actually dramatical cost reduction in the IoT related data plans. Some of the public data says for specific plans like $10 for 10 years. And you can imagine that in private conversation, numbers are even better. So if I only need to collect a small amount of data from the vehicle, the connectivity piece, which is once was tens of dollars per month, now could become a cent. And I can imagine a device which can monitor your vehicle behavior, which could cost, I don't know, between 10 to 20 bucks, including the connectivity. And by reducing those, you mentioned earlier the guys components generate value, but it takes money to move this data from one point to another. And the lower the cost of moving the data from the edge to the cloud, the more and more people will find the creative ways what they can do with that data. And this is why it's booming. We see it in vehicles and extremely strong in the logistic industry.
You're right. This is a very, very interesting market development, right? The business search for business models is really driving innovation around the cost structure, right? Because it's very hard to build a business model for a low cost device if the connectivity is going to.
Yeah, and I think the business model. Well, I think if we are not talking as end customers, but for B2B, and this is where most of the IoT devices are going to today, I think a good business model is extremely important to actually justify the investment and build end-to-end solution. Because even today, and we actually would like to have much quicker design and deployment time, and it still takes probably 12 to 18 months, and we actually do a lot to shrink that. But it still takes some time between you come with an idea till you can deploy a significant number of devices. And you need to justify that to your management and invest and have funds invested in that activity. You really have to come with a very good business case.
So then maybe last question from my side, Dima, would be when you're working, especially with maybe your larger customers where you're working with them a bit more closely, how involved do you get in these discussions of the business case or helping them to understand beyond the core technical functionality? How deep do you get involved in these conversations?
I think this is probably one of the most exciting parts of my job, that I get to meet many of the end customers and not only the direct customers. It's typically very secret, those discussions, but we know many of those use cases and business cases. And I think one of the reasons we really want to be so involved, it's of course interesting. So we're all human and attracted to interesting things, but we also open the eyes for some of the innovation managers within those companies about what you can do with the cellular technology. The most advanced ones know everything, and they know the business case, they know the technology, they can teach me many things. And this typically happens when companies doing their second or third project. But when they do their first project, you would imagine that the innovation manager within the organization will be highly skilled expert within his area of interest. For example, within an agriculture company, they will know everything about the seeds and what problem their customers have, and when they use them properly, and how to store seeds properly or improperly. But this is where we come to the game, and we help them together to shape the product they need. So they have a problem, we have the technology, And for a small amount of really strategic relationship, we are exposed and we can build those great solutions together.
Okay, fascinating. Good. Well, Dima, I've really learned a lot here. So I really appreciate you taking the time to speak with us. As I said, this is a critical technology, but because it's a bit hidden under the hood, it's something that me and probably many other people in this area know too little about. So really appreciate your time. How can people reach out to you or your team or to Sony Semiconductor in general to learn more about what you're doing, and also if there's an opportunity to collaborate?
Oh, there are so many ways. One is social media, LinkedIn, either for myself, which is Dima Feldman at LinkedIn, or today we are still Altair Semiconductor, which we are in transition to change the name. So this is one of the easiest ways. Second, of course, the website, altair-semi.com. And actually, I would really appreciate if we can publish those links with the podcast so people would have a good way to reach us.
Yeah, very happy to. I'll include those in the show notes. Well, Dima, again, thank you. Appreciate your time today.
Okay, great. Eric, it was a very interesting and great question. Thanks.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT ONE HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.